Hello and welcome back to Stats Coach. Today we're going to be discussing how to know when to reject the null hypothesis. In most introductory statistics courses, this is a concept that can be somewhat confusing. So here we cover the three main ways of testing a null hypothesis and how to know when to reject. Before we get into it though, if you're unfamiliar with null hypotheses and how to construct them, this slide is for you. So the null hypothesis, remember, is always that there is no difference. So the way I like to remember that is null is dull. So a short example down below, if a company is coming out with a new type of pizza and they want to determine if the new flavor increases their sales, the null hypothesis would be that it doesn't. So that would be the null hypothesis is that it decreases sales or sales stay the same. Therefore, the alternative hypothesis is that it does increase sales. So the alternative is always the opposite of the null. So that was just a quick recap of null hypotheses. But the three most common ways of testing a null hypothesis, first you might compare the p-value to alpha, or you might compare a t-statistic to a t-critical value, or you might compare an f-statistic to an f-critical value. These are the three most common ways in an introductory statistics course, so I figured I'd cover them here. The p-value method, if the p-value is less than or equal to alpha, you reject the null hypothesis. If the p-value is greater than alpha, you fail to reject the null hypothesis. Remember here that alpha is always 1 minus the confidence interval. So most of the time, the most common occurrence is that the confidence interval is 95%. So alpha, therefore, would be 1 minus 0.95, which is 0.05. So alpha is most commonly 0.05. So if we're testing to see if the p-value is less than or equal to 0.05, that's how if it is, then you would reject. For the t-statistic method, if the absolute value of the t-statistic is greater than or equal to the t-critical, then you reject. If it's less than the t-critical, you fail to reject. So here we have an Excel output of a t-test. It's a two-sample t-test assuming unequal variances. And these two machines were to be packing coffee beans inside of a package to sell it, and the machines are to put 18 ounces of coffee beans in each package. So we're testing to see if the machines are putting the same amount in. So here we have a t-statistic of 0.2878. We have a t-critical value, if it was one-tailed, of 1.6558. and a t-critical value of, if it was two-tailed, of 1.9771. So if we're rounding. So we can compare that t-statistic to the appropriate t-critical value. In this case, we're using a two-tailed test because we're testing to see if they're different from one another. So if machine 2 is greater than machine 1, that is significant. And if machine 2 is less than machine 1, that is significant. If we were only testing if machine 2 was greater than or equal to just one of the two, then we would be doing a one-tailed test. But for our case, we're doing a two-tailed test. So we compare the t-statistic to the t-critical. The t-statistic is less than the t-critical. So based on our rules, we are failing to reject. We also know this because the p-value, which in this case is 0.7739, is greater than our alpha, and we can assume here that alpha is 0.05. So if we're testing at 95% confidence level, we compare the p-value to the alpha 0.05, and we also fail to reject. The key here is if you fail to reject with the t-statistic, you'll also fail to reject with the p-value. So you'll never get a different answer. So if you test with one, you don't have to test with both. The f-statistic method, if the f-statistic is greater than or equal to the f-critical, then we reject. And on the other hand, if it's less than, then we fail to reject. So here is an ANOVA output. We have 3 farms, and each of the farms is producing 100 potatoes, and the potatoes are weighed. So we want to test to see if the farms are producing the same size potatoes in weight. So we have an f-statistic here of 50.48 versus an f-critical value of 3.03. So the f-statistic is much larger than the f-critical, so we are going to reject. The other way we might know this is the p-value is very, very small. So this e to the negative 19 means that there's 18 leading zeros, so 0, 0, 18 zeros, and then 1, 3, 4, that means that the p-value is much smaller than our assumed alpha of 0.05. So we also are going to reject using the p-value method. And again, the rule still applies, where if you reject using the p-value, then you'll always also reject using the f-statistic test. And conversely, if you're rejecting with the f-statistic, you'll always reject with p-value. So the answer you get with one is always the answer that you get with the other. So that was a quick review of the 3 most common ways to test a null hypothesis. If you have any further questions, feel free to comment down below, and I hope this video helped you. If it did, I would appreciate a like on the video, and I wish you all the best with your statistic endeavors. Thank you.